Hey everyone, welcome back to the workshop series for the next video build, sponsored by, of course, Livepeer. Today we have two more workshops back to back. First, we have Polygon, and secondly, we have Ceramic coming in about 45 minutes. Before we get started, we'd just like to say I'm the program manager of the hackathon, and if you'd like to find out more information, I would direct you to the following link here, where you can see all the dates, like for example the submission date, which has been pushed back a couple of weeks until January, so the 8th, I believe. So for any of those links and information, check that out. Next, I would like to introduce Steph from Polygon, who's going to be giving us a workshop on building a full stack dApp. So how are you doing, Steph?
I'm doing great. I am coming at all of you from Los Angeles, California. It's a super sunny day, and excited to present today.
Awesome. Well, we're really excited for the workshop. So without further ado, I will hand over to you.
Awesome. Okay, so we have two different things that we could do. I think a lot of people are part of the Solidity Bootcamp already. Is that correct?
I believe some people are, some people aren't. Yeah.
Okay, so I'll do a more advanced version then, since probably people have seen how to deploy a smart contract and all of that. So let me share my screen and I'll show you all what we're doing today. So this is the front end that we will create, or I'll show you how to create. As you can see, I'm not really a great front-end developer. I'm not a CSS person, so I'm sure all of you will have much prettier builds for your hackathon. But today we're going to talk about building a full stack dApp with Polygon ID, which is Polygon's decentralized identity solution. So we'll walk through how to create a smart contract that interacts with a front end so that you can have a full stack dApp that's using a really cool decentralized identity solution. I know this is a relatively new product, Polygon ID, so we'll get into a couple different things about that first. I see something in the chat. Let's see. I'm just on my laptop, so I can't see all of the messages. Oh, somebody said, I would like to put this on GitHub. Cool, great. Okay. So I can't see all of the chat, so if you ask questions, you might have to call something out so that I know that it's there. But feel free to stop me if you have any questions through this. It'll be about 45 minutes. I think we might be at 40, and then I'll give you 5 minutes for questions. But like I said, we're going to talk about building a dApp with Polygon ID today. But first, GM everyone, I'm Steph. I'm a developer relations engineer at Polygon, and I'm also Oceans404 on Twitter. This is my profile pic. It's a little doodle. And I don't know if you noticed, but I just told you 1, 2, 3, 4, 5 things about myself. I said, this is my profile pic, this is my name, this is my title, this is my company, and this is my Twitter handle. So those are all personal identifiable information pieces about me. And you might be thinking to yourself, or actually you're probably not thinking to yourself, that's not true, because we've established a little bit of trust. I'm here as a presenter. So you probably assume that every piece of information on this side is true. And it is actually. But let's think of a situation where maybe 2 police officers or 2 authorities pull someone over and they say, hey, what's your name? And this person, or I should say this sponge, says, my name is SpongeBob SquarePants. And they go, yeah, right, show me some form of identification, sir. Because you don't want to just trust people or sponges when they tell you who they are or facts about themselves. You should verify. Don't trust, verify is kind of a Bitcoin maxim from way back when. I feel like it was probably in Greek or something originally, but people say don't trust, verify. And that's one of the really powerful things about blockchain. You can verify things on chain. So imagine that SpongeBob has a name tag and it says his name, but it's written in pen and it doesn't look very official. It seems like maybe somebody just scribbled down a name. So it's not really a very trustworthy form of identification, because there's still no authority that's issued this, or we have no way of knowing that this is true. So a slightly better way for him to identify himself is with a verified credential. And one example of that is a driver's license. I'm just going to move this because it's getting in my way a little bit. I don't know if you can see my little Zoom screen thing. I don't know how to hide it. I'll just put it up here for now. Okay, sorry about that. So a verified credential is a better way for SpongeBob to show the police or the authorities that he is who he says he is, because this is a bikini bottom driver's license. It's something that police or other authorities know to be given by the DMV. And so this is a verified credential because we can trust that whoever gave out the credential is a trustworthy person. So let's say that the police just asked for SpongeBob's name. Why does he have to show this ID that has so much other information? It says his expiration date, his license number, his address, sex, hair color, eyes, height, all of this information plus his signature. This is a lot of data that doesn't really answer the original question they asked, which is, who are you? So why do we need all of this? Let's get into the trust triangle. This kind of describes the relationship between the three people in this situation that make that verified credential authentic. So the first thing is the issuer. In this case, it was Mrs. Puff's boating school. So she has a DMV type of place that tests the holder, makes sure that they can drive, and then issues them a license. That can be verified by the police officer or an authority, and it is trusted because the verifier trusts the issuer. So this is where that verified credential comes in. So Mrs. Puff issues SpongeBob a verified credential, a driver's license, and then the verifier can check the driver's license and trust the issuer. And you can see there's a little hint at this top right-hand corner. And that's because with Polygon ID or other decentralized identity solutions, instead of showing someone your full verified credentials, what if we could just use a proof, a ZK proof, and show the verifier the ZK proof, and the verifier can say, okay, the identity of the ZK proof belongs to the holder. The holder is also presenting me with this proof. Because those two identities match, I can trust that the issuer has actually issued this verified credential and the information is accurate. And so that's what we're going to build with today and get into a tiny bit more. So I have two different examples of verified credentials just to drive this point in. The first one is a student ID. So in this case, the issuer would be an admissions office. So college admissions office, like the admissions office at UCLA. I'm a Bruin. And so the holder is a UCLA student. In this case, it's Josie Bruin. They have a ID and it says they're part of the staff. So this person is on the staff, but imagine that they're a student. So this person's a student and they're going to take a midterm. In order to show that they are who they say they are at the midterm and turn in their test, the professor is going to check their Bruin card, their student ID, against the name that they're submitting with the test. And so by checking those two things together, the professor can say like, yes, this student is who they say they are. Imagine if we could do that without having to show the professor the ID, because why do they necessarily need to know your ID number or maybe like where on campus you live? They probably don't. The next example is a COVID vaccination card. So this is a verified credential and it's issued by maybe a nurse at CVS or a hospital, and then they write in your doses. So this person got a Pfizer on the 17th of December in 2020 by this nurse. And so the holder of this verified credential is a vaccinated person, and maybe the verifier is a bouncer at a bar. So the verifier says you need to be vaccinated to come in and drink at this bar. So whoever is walking in says, here's my COVID vaccination card. But again, you're giving away a lot of personal information to this bouncer. And all they really want to know is that you check the box for data, not data access in this case, but access to the bar. And so this is the pattern that we're trying to create and then make more secure. That pattern of we have something that is information that can be verified, and we don't want to necessarily reveal all of the details about that information. It just has to pass certain checks. So in this case, I don't want to have to show a bouncer at a bar my whole vaccination card. All they need to know is that, yes, I'm vaccinated and my shots are up to date. So those two examples were both examples that are analog, they're physical. But today we're going to be talking more about digital verified identity. So in the same way that we sometimes give away too much information, or TMI, about our analog identities, we also do this with our digital identities. So I don't know if you've ever signed up for Facebook. Probably no one's done this in the last few months. But the sign up, it says it's quick and easy. And then it asks for all of this information: first name, last name, mobile number, email, password, birthday, gender, and maybe even more. You can give away even more on your profile if you want to. So this is a lot of information, and we're in a day and age where you don't want to be giving up all of this unless you absolutely have to, but it's required to create an account. So the next thing we'll talk about is self-sovereign identity, which is a new type of identity that empowers us to receive digitally signed credentials, store them in private wallets, and securely prove our online identities. That's a lot of words, but maybe you're starting to pick out some things that sound like blockchain concepts. And if you're thinking that, you're completely right. So self-sovereign identity doesn't have to be something that has anything to do with blockchain or live on a blockchain. But we found that these two technologies of like self-sovereign identity and Web3 are really complementary. And so in this type of system, you as an individual, or maybe your company as an organization, or your family, has ownership over digital identity, and you can also control how your personal data is shared and used, so that you don't have to give up all of those pieces when you're logging into an app like Facebook or any type of social app, like the ones you might be creating through this hackathon. So I'm just going to run through centralized identity and federated identity really quick to give you the three types. So again, we're going to be talking about and working with decentralized self-sovereign identity, but there's also centralized identity, which is like logging into one website with a single email and password. This is a problem because it's very siloed. It's not portable from app to app. So you end up managing tons and tons of different logins for all of the different apps. And then I don't know about you, but I have such a headache anytime I have to add a new app to my password manager. I'm like, another one. So that's centralized identity. And it gets a little bit better with federated identity, where you use your email or your phone number, or you can log in with one of these other apps. So you're essentially creating a single multi-purpose account to reuse as you log into different apps. At my work, we use something called Okta, and that is how I sign into everything. So it's kind of nice and it's more portable, but it doesn't work for every app. And let's say I lost access to my Google or something, I would not be able to log into, I think this is a screenshot from Uber Eats. So that would be a bit of a problem if I was hungry, or if I had canceled my Google account or anything like that. And then also the problem with this is a big tech company, whether it's Google, Apple, or Facebook, has your data across all of these different apps. And we've seen, like, if you log in with Facebook, it says what you're giving away your permissions for the Facebook app to have access to, and it's usually pretty invasive. So not everyone is comfortable with that. So that's a little bit difficult about federated identity. It's a lot of trust. And so the solution I'm proposing today, and what we'll be building with, is decentralized self-sovereign identity. And Polygon ID is one of the different solutions that we can use for this. But this is powerful because it's multi-purpose and portable. So you can prove pieces of your identity, whether it's your name or your birthday or your country of origin, just one time. And then you can use that to log into any app or to prove something on any app. And you are the only person who retains control of that personal information. And so therefore you own that piece of your digital identity. And it's not something that's necessarily shared with apps. And that eliminates those third parties from accessing those pieces without you giving them access to them. So essentially, the selling point is that you can prove access rights without giving up your data. So you can prove you're over the age of 18, or you can prove that you're a citizen of Bikini Bottom without having to say, like, here's all of this info, and yes, I am also living here, and my birthday is this. Like, none of that matters. You don't have to do the TMI stuff. You just prove what you need to prove without giving up the rest of it. So this is Polygon ID. It's a scalable blockchain ID with ZK-based privacy. So some people, I actually got a question about this yesterday, and someone asked, is it like an ENS since it's a form of identity? And the answer to that is not really. ENS is more of like naming your Ethereum or EVM compatible accounts, and Polygon ID is letting you input pieces of your identity and secure those pieces with ZK proofs so that you can use them across all of these different apps. So it's a universal identity, but your identity is made up of tons of little pieces based on things about you. So again, you can prove your access rights, not identity, and you can use either on-chain or off-chain verification of those proofs. And we'll get into that a little bit more soon. Okay, so this is a video.
As the boundaries between our offline and online lives continue to blur, the significance of one's digital identity is becoming more and more apparent. Currently, it's difficult to prove your identity without revealing sensitive, private information. Polygon ID offers a decentralized, self-sovereign, and privacy-focused identity management solution for Web 2 and Web 3, powered by zero-knowledge technology. It enables users and enterprises to maintain privacy and retain full control over their digital identity. Thanks to zero-knowledge proofs, everyone using Polygon ID can prove any aspect of their identity on-chain without having to disclose personal information. Where can you verify your identity with Polygon ID? The answer? Pretty much everywhere. Moreover, differently than centralized identity management solutions, it allows any user to create zero-knowledge claims, guaranteeing freedom of expression for users, issuers, and verifiers. Polygon ID lays the groundwork for societal transformation by providing a platform that makes freedom of expression, digital inclusion, and programmable privacy finally possible. The future of digital identity is here. Stay tuned for more.
All right, so my marketing team would have killed me if I didn't show that video. It's fun. But Polygon ID's guiding principles are decentralization, privacy, trust and reputation, and being open and permissionless. The priority is keeping people like us safe and keeping our identities private. So this is one last look at the SpongeBob analogy before we get into how this actually works on chain. And I'm gonna check the chat really quick. Audio works, awesome, thanks. So again, there's an issuer, a holder, and a verifier. The issuer gives a holder a verified credential like a driver's license, and then the verifier can just check with the holder that they are the holder of a ZK proof. And this works because the verifier trusts that the issuer would only issue a verified credential to people who meet whatever criteria they're looking for. So in this case, Mrs. Puff only gives SpongeBob a license if he actually passed his driver's test. And during that, she has verified his identity is who he says he is. So the verifier can look at this ZK proof, and all they're getting is the ZK proof that SpongeBob is a certified driver or that his name is SpongeBob. Any of these little pieces of his identity can be proved. Okay, so this is what this looks like in the Polygon ID, I don't know, not atmosphere, but the Polygon ID system. So the issuer in this case is either a UI called the Polygon ID platform, or we actually just released these really cool new APIs that let you programmatically issue claims. I'm going to show you from the Polygon ID platform front end because I think it'll just make more sense conceptually, but just know that you can programmatically issue claims. Then those claims live in your Polygon ID wallet app. Looking something like this. This is a KYC age credential. So in this case, someone, which is me, the identity holder, has gotten a claim that my age is whatever my birthday is, essentially, and it lives in my app. in my Polygon ID wallet, which is on my phone. Then I can generate a ZK proof to prove my age, and a verifier, which in this case is a smart contract, can request the proof, verify that I am the age I say I am, or I'm older than a specific age, and do some type of logic. And in this case, we're going to claim an ERC20, so a token airdrop on Polygon Mumbai based on my birthday being before the January 1st, 2001 date. I don't know how old this would make me, 21, older than 21, I think, something like that. So you have to be older than 21 to scan this QR code and claim the token airdrop. So this is the front end, and I'm going to show you how to create a claim and build a smart contract that we can hook up to this front end so that if you're over 21, you can scan this link and claim your tokens. They're not worth anything, so no financial reason to claim, just for fun. Okay, so this is kind of the problem statement, and it's slightly different. Oh, I think my AirPods just died. I'll just take them out. Okay, it's slightly different than that over 21 use case. But this is a problem that a lot of social apps, including Instagram, have. So Instagram and other social apps require users to be over the age of 13 in order to use the app. And they do this by asking you randomly to add your own birthday. So you have to add your birthday in order to say, like, yes, I'm over the age of 13 and I'm allowed to have an Instagram account. And actually, my mom got this pop-up a couple months ago, and she was really lazy and didn't want to like scroll all the way down to the year that her birthday is. So she just changed the month and the day, but the year was still 2022. So it looked like she was under the age of 1. She saved her birthday and completely got locked out of Instagram because you have to be over 13 years of age to use this. And she was annoyed because she was like, I don't want to give up my birthday. I'm obviously over the age of 13. It's fine. I can use this. But we could use something like Polygon ID to solve for this problem so that someone like my mom can use the app without actually having to give up her birthday. So let's check out the issuer platform. I'm going to paste this link in the Zoom so you all can check this out. Oh, it's making me sign in. Okay, so the first thing I have to do is sign into my account. I already have an account, so I can just do it like this. And now I see a bunch of my schemas and also offered claims. So I'm going to create a new claim. And if you remember from this, or this one actually, the claim acts as that verified credential. So I'm going to issue myself a claim about my age. And this is not a real KYC'd age credential. KYC is know your customer, which is something you do at a lot of banks or DeFi apps to prove that you're in a certain country. So this is not a real legit claim that I could use to get into a bar or to use a social media app, but it's mostly just to show you this is how I would issue myself an age claim. So I called it my age. The data type is not a Boolean in this case, it's a date. So I'll be able to issue myself a date age. I'm not going to add an attribute description, but I could. And then the other optional parameter is an expiration date. So maybe you're giving away like a claim to claim a concert ticket, and the concert is next week. So maybe you want that claim to expire next week. But I'm not going to add this because my birthday never expires. So I'm going to add my age. My birthday is not November 1st, but let's pretend it is, and I'll say it is in 1990. So November 1st, 1990 is my fake birthday. And I'm generating that claim offer. You can see it's the schema name is my age, the attribute is this date, and there's no expiration date. But now I have a link to a claim offer. So I'm just going to copy this and I'll open it in a new link. Okay, so I've received a claim offer from my organization is called Steph. So I can scan this QR code with my Polygon ID wallet app to add the claim to my wallet. So I already have the wallet app
on my phone. So if I scan this, I should be able to add this claim to my wallet and I'll be able to see it. So I'm just going to do that really quickly. This is my wallet app. I'm just going to connect. So you can see I'm connecting my wallet. It's authenticating. My identity has been authenticated. And then I should see it very soon in my data. So these are two of my claims that I already have: proof of personhood, and KYC age credential. And you can see like there's a little bit of information inside of my wallet app about those. So once I have this claim, I can do other things that I'll show you next. Okay, so this is just if the demo hadn't worked. An issuer creates claims within the ID platform or with the API. It issues claims to real people like me or maybe you. I could issue you your birthday. And then you can claim these using the Polygon ID wallet app. So if you have an Apple phone or an Android, you can scan these two different links to get this Polygon ID wallet app. And that way you'll be able to hold your own claims from your phone so that you'll be able to do things like scan this, and then it'll check against your claims to see if your birthday is before January 1st, 2001. So I'll give everybody like 10 more seconds to scan. And we'll keep going. Okay, so this is what the wallet app looks like if you aren't able to download it or you don't want to quite yet. You have your claims within here. If you click into claims, you see each of your different data claims. So maybe that's a DAO membership, maybe it's proof of personhood or country of origin. And so once you have those claims, you can interact with any different Web 2 or 3 service that is asking you to do an age verification or any type of verification. And these verifications are done via QR codes. So from your phone app, you scan a QR code, it checks against your claims and then says like yes or no, you can do whatever the logic is that you've programmed in. So it does that by generating a proof, and then you share your proof with whatever the smart contract is. And I don't know why that slide came back up, but that's kind of the logic of how you would program this in. We had a couple different really cool projects at ETH Bogota that used Polygon ID. One of them was called PUMP, Private Under-Collateralized Lending Protocol. So you can prove your reputation without actually having a real credit score. So instead of having a credit score, you could verify things like your age or that you belong to a DAO, that you completed college or you're a community member. And if you have two of these reputation proofs that are valid, you're able to borrow money, which is pretty cool. So it looks like in this case, somebody was over the age of 18 and they also were an active DAO contributor. So this claim, the age claim, is probably that KYC age credential that we saw before. And then the DAO contributor claim could be issued by a DAO like Developer DAO. Maybe all of the members say like, if you have a certain number of the code token, you are eligible to do something. So you could do that with Polygon ID. So if you want to learn more about Pulp, here's the QR code for that. So you could do a project like this. Somebody also created a really cool chat app to chat with, so that VCs and projects could chat with each other and understand like the VC is qualified to chat because they have X amount of money. The project is qualified to chat with the VC because they have N number of GitHub commits, something like that. There was also Orchid Wallet, which was kind of like a multi-sig, I believe, super cool. And then there was a ZK voting app that helped you stay anonymous as you voted within your DAO, which was also pretty cool. So I have a bunch of links to different Polygon ID docs and resources, but what we're going to look at is a tutorial that my coworker Manny created. It's really great. But first, if you want to look at the Polygon ID docs, they're right here. They have those core concepts of ID like claiming, that triangle of trust, all of that. There's also a tutorial for how to do the on-chain verifier. So just like what I showed you with this claim. So you'd be able to scan from a front end, and then it would connect to the smart contract to make sure that you had this KYC age credential. But let's get into it. I'll send you this link to, oops, sorry. Oh, somebody said, can you show the QR code ones? I think it's actually linked inside of Manny's tutorial, so you can grab it from here. Yeah, so you should be able to see it within here. Okay, so within this Polygon on-chain verification code, you can see concepts, and it's that same tutorial, deploy an ERC20 token. I really like the way he wrote out his README. It has some error logging. So even though that tutorial does exist on the docs, I recommend you look at Manny's version, just because you'll see some of the different errors you could run into when you're building your full stack dApp. Let's see, we have the link to the slides. Of course, let me grab you that link really quick. Okay, so if you want to follow this tutorial and create your own full stack dApp, all you have to do is create an env file, add these different API keys, your Mumbai URL, because we're deploying the ERC20 token to Polygon Mumbai, also your wallet private key, that will be whichever test wallet you're using for this. So the first thing you do is you deploy the ERC20 contract. That's a really classic, just like token contract, probably very similar to something you've seen on OpenZeppelin. So there's not really a lot of magic in that. The next thing you have to do is create a claim. So in this case, it was that age credential that we just saw. I think Manny's example just uses a custom attribute for some reason. There's a couple different data types you could use that aren't age, and one of them is number and one of them is Boolean. So he just showed a different type of claim creation. And then this is that claim. Remember, you can use the claim link to claim it inside of your Polygon ID wallet app. You've received a claim offer. The problem with the UI version of this right now is that you can only send a link is unique to a person. So you can't send all of your friends that same claim link. You can only send one to Manny, one to Rahat. But we also just released Polygon ID APIs, platform iPad. Nope. Let's see. I don't have a link handy because we just added them, but the documentation hopefully has these. I tweeted about it yesterday, so maybe that's the best way to find it. Here we go. Okay, so I'll post this link really quick, but these Polygon ID platform APIs are the other way that you can generate claim links programmatically, which is super cool and powerful for builders, just because this way you're not doing one by one links and like sending them to each person. You're doing them in a programmatic way so that you could claim them from a UI if you wanted to. So these are those platform APIs. So instead of using this UI, you could use these APIs to claim offers or to set up an issuer if you wanted to. But for the hackathon, feel free to just use something like this and say, like, we didn't build out this part yet, unless you ended up doing it. I guess you've got a month still. But this is just Manny walking through how to claim, generate everything. And this is where in a second smart contract, you're setting your ZK proof request. So you match the schema hash to whatever was in the claim that was part of the ID platform. Oops. So back in that platform app, I'll just show you one really quick. So in this case, the schema hash would be this field. So you would copy that into schema hash. The ERC20 verifier address is just whatever the contract address was that you deployed previously for your ERC20 token. This is just doing some magic with the schema hash, and then you set up your query. So you shouldn't have to change any of this. It's just constant. And then the last thing you do is you run the second script, which is just setting that ZK proof request so that the script knows what proof you're proving against. So that schema hash that you created, you have the ERC verifier address, and then the rest of the query stuff is in here. So this is not actually checking like, is your birthday before or after a certain day? That's all happening in the QR code. So I'll show you that next. So this is all up to step 4. This is all your smart contract. And so it's really not that much code that you have to change or do anything with. But the QR code proof request, which is that front end, is how you're checking. So the first thing you have to add to the QR code is that deployed contract address. So this will match. Actually, so this is a little bit confusing. Instead of matching this deployed contract address to the ERC20, you're matching it to something slightly different that's generated after you run this script for the proof request. So you have the deployed contract address. And then here's the data that goes inside of the proof request. And actually, it's probably easier if I show this within that front end. Okay, so on the front end, this is where that ZK proof request lives. And it's something that just goes into the QR code. So this is the object that we're injecting into the QR code. And then if you look down here, there's something called QR code, which is just a React library, which creates this React component. So the value we're injecting is a JSON stringify of the QR proof request, excuse me. And so within this proof request, we have an ID. I don't think you have to change this at all. You don't have to change any of these lines up through the deployed contract address, which in this case is just this address. The network is Mumbai. The reason doesn't really matter, but in this case, it's airdrop participation. The circuit ID will always stay the same. If you only wanted certain allowed issuers, you could specify their addresses. But in this case, we've said allow all issuers. And this is where the magic happens with the query. So the request is saying your birthday has to be LT, which is less than January 1st, 2001. So I just broke it. But this is just a date string. So we're checking that birthday is LT less than this date. And so if you scan this and that birthday field is less than this, you should be able to claim an airdrop. And so with Manny's example, you can see this is what happens when you scan that front end QR code. So you're able to mint. So you scan from within your Polygon ID wallet app. And within that app, there's a proof request for airdrop participation, which is that reason. And you can see that it was a custom schema. And these are the requirements for his. His was just that a number is bigger than 10. So this generates a cryptographic proof within your ID wallet. And then it asks you to open whatever your personal wallet is so that you can claim the airdrop. So in this case, I think he probably picked MetaMask. Yep, it opens MetaMask and it asks, would you like to connect to the site? He clicks connect. It shows all of his accounts and generates that proof. And so this is all happening in the wallet app. You don't have to code any of this part. It's just going on behind the scenes for your user. So you can see here, it's asking if he would like to claim, confirm, and then within his data, or actually, I'm not sure why this is there, but maybe the app goes back to your wallet afterwards. But after you hit confirm, you can see in Polygon scan that this transaction is confirmed, and you've actually received that airdrop of whatever the token was. And so within Manny's tutorial, he also has a few different debugging errors. So like if you forget to change the claim schema ID or hash, this is the example of a error message you would see. and just some other different things that could go wrong. Your type has to match whatever you put within the Polygon ID platform app. So my schema name was my age, and the type was date. So just a few more things. And then here are some other things that you might be checking against. Maybe you're looking for if your date of birth equals, like if you were born on a leap year, for example, or maybe you're looking for less than greater than, if that was date of birth, that's pretty obvious. And then these are some other operators that you could do. And then those correspond to these different numbers and little strings. So if you're doing this from within the request, you're using a value for your operator. So 3 is greater than. But if you're doing this within your front end, you're using that like language. We were using LT, which is less than, which is the value of 2. So in your query, you would use 2 as your operator rather than 3. Just a little bit more debugging. And yeah, this is, I guess he also did an example with the ability to claim a NFT based on certain aspects of your identity. But that is this tutorial. I'll post it one more time so you all have it. But yeah, I know we only have one more question, but one more minute, but does anyone have any specific questions that I could answer about ID or about how to build a dApp with it? You have 2 examples, and then you also have the API platform introduction. So I think that's everything you should need, but I'm also open to answering questions either on Telegram or Discord.
Well, thank you so much, Steph, for the presentation. It was really interesting. Yeah, we have 1 more minute, guys, so we have probably a chance for a question or 2.
If not, no worries. I'm all over the internet. I'll also give you my Twitter. People like to tweet me questions as well, which works.
If there's no more questions, I think we will wrap up this first workshop. Thank you very much, Steph, for coming in today. It was really, really interesting. And I hope we see lots of good projects using the tech you've demonstrated today. So thank you.
Awesome. Thanks, everyone. Have a great day.
Thanks, Steph. Have a good rest of your day. Goodbye.